This is Compiling a Career, Predicting Success in Computer Science. From 2012 to 2022, the number of students studying computer science doubled, but job demand stalled, and computer science now ranks fifth in the highest unemployment rate by major. As computer science students ourselves, we started to wonder what factors most likely affect the chances of getting a job in computer science adjacent fields. In order to analyze this, we found a dataset consisting of 70,000 plus job applications. In particular, we wanted to focus on a couple variables, which were age, gender, education level, years code, which included the number of years an applicant spent coding, years code professional, which included the number of years that applicants spent coding professionally, computer skills, which included the number of programming languages known, and main branch, which indicated whether applications had been a professional developer before. Some potential shortcomings of our dataset are its high male bias, no primary sources listed, and no time range.
So we ran a couple of EDAs on this data set and made some interesting observations. From this specific group bar plot, we see that the proportion of unemployed individuals actually increased with respect to an increasing degree of education level, which really surprised us because we thought the opposite relationship was true. And we also see that the unemployment rate for females remains the highest in the gender category. But the accuracy of this statement is undermined because our dataset is highly skewed towards the male population, with males consisting of 93% of our dataset. From the first four histograms, we see that there's significant overlap between the employed and unemployed classes for each of these variables, which shows that they're not reliable predictors for employability. But for our histogram of computer skills, we see that there's very little overlap between the two classes. And for a low number of computer skills, the unemployed class is pretty high. It dominates. And as the number of computer skills increases, the unemployed individuals decrease and the number of employed individuals increases. And so this means that computer skills is indeed a pretty strong predictor of determining a candidate's employability.
For our primary analysis, we conducted forward selection to evaluate which of our variables was most predictive of employment. How forward selection works is it starts with an empty model and tests all available features one by one, and identifies the variable that identifies the most significant improvement to the model's fit, then repeats and adds the next best one that improves the model's fit. And since we were predicting employment, which is a categorical variable, we did logistic regression and measured that with a variable called McFadden's pseudo R squared to measure how well our model fit was to the actual data for who got employed. And our three best predictors were computer skills, main branch, and ed level, achieving a combined pseudo R squared value of 0.3536, which indicated a really good fit onto the data of who got employed. And here is just a picture of our output showing our three variables, computer skills, main branch, and ed level, and that they achieved a higher pseudo R squared than the rest of our variables.
For an additional analysis, we used a gender stratified logistic regression model, which can help us see whether the predictors from our full dataset model were still consistent across gender groups. Since our dataset was predominantly male, we first created a balance sample by undersampling, which kept all female and non-binary respondents and randomly sampled an equal number of male respondents to match that combined group size. After balancing, we ran the logistic regression model for each group and plotted their odds ratios on a plot. Overall, the stratified model was consistent with the full dataset model, with computer skills being a consistent predictor across all three groups, supporting the idea that the predictors were not completely caused by the dataset's large male sample.
The main finding was that computer skills was by far the strongest predictor of employment. This result was consistent across both our visualizations and logistic regression model, where we got a pseudo R-squared value of around 0.35. In contrast, demographic factors such as age and gender showed relatively weak relationships with employment outcomes. We were even surprised to see that education levels, as well as professional coding experience, were weaker predictors than expected. Overall, these results suggest that employers place greater value on practical technical skills rather than traditional credentials. These findings also have a broader implication for the technology industry. With AI and other technologies rapidly advancing, the skills that employers need are constantly evolving. This means that maintaining relevant technical skills and staying up to date with new technologies is becoming increasingly important. As a result, employers are looking for individuals who can adapt to changing industry demands, and long-term success in these fields depends on a person's ability to continuously learn and apply new skills.